Hello, my dear students. Welcome to my YouTube channel, that's Concepts of Chemistry. So, before starting today's lecture, please do subscribe my channel. My dear students, today we are going to study the topic that's discovery of neutrons. The discovery of neutron was actually made after the 20 years the structure of atom elucidated by Rutherford. In 1920, Rutherford has found out that the mass of an atom is much more greater than the mass of total protons in the atom. In the Rutherford model, I have made you understand that the mass of proton is 1837 times the mass of electron. So in practicality, the mass of an atom will be the total mass of protons. But Rutherford find the mass of an atom to be much greater than the total mass of protons. So Rutherford concluded that there must be some more neutral particles in the nucleus which have the mass equal to that of the protons. So let me write this thing. Now I'm writing first of all the discovery of neutron. The discovery of neutron was made after 20 years the after 20 years the establishment of Rutherford model. The establishment of Rutherford model. Now, what Rutherford has observed, I'm writing in 1920. Rutherford observed that Rutherford observed that mass of an atom is much greater is much greater than the total mass of protons present in the nucleus. Present in the nucleus. So according to the observation, Rutherford proposed that Rutherford proposed that there is presence of some neutral particles of some neutral particles in nucleus which has mass equal to that of protons. So this concept was further taken by James Chadwick sir, and he has attempted an experiment to find out the presence of some particles in the nucleus which were neutral in nature. So in the year 1932, which scientist? The Chadwick James Chadwick the scientist James Chadwick performed an experiment. What he has done in his experiment, he bombarded the alpha particles. He bombarded the alpha particles on beryllium atom. After striking the beryllium atom, the new set of rays were emitted, which were not deflected in the electric and magnetic field. That rays were also the particle rays, so the particles in that rays were neutral in nature, which were named as protons. So I'm writing, after bombardment, the new particle rays were emitted, which were not deflected in electric and magnetic field. So that particle rays were not deflected in electric and magnetic field. So it confirms that it confirms that particles were neutral. Particles were neutral in that rays, and that particles are named as neutrons. So I'm writing now the nuclear reaction which has emitted the particle rays of the neutrons. So I'm writing that nuclear reaction. So we have taken beryllium with an atomic number of 4 and a mass number of 9. The alpha particle strikes the beryllium, so there will be the changes in the number of protons in the nucleus, so new atom will arise, or that beryllium will be converted to the new element, that's carbon. The element gets converted to the another element when the nuclear reactions takes place, that we will study in the radioactivity. When the number of protons or neutrons changes in the nucleus, the one element changes to the another element. So here the beryllium gets converted to the carbon with the atomic number of 6 and the mass number of 12, plus there will be the emission of one neutron with the mass number of 1, but the charge on neutron is 0. So these were the neutron rays which were not deflected in the electric and the magnetic field. So what happens actually in the nucleus? The neutrons and protons are interconvertible. So that's the new thing I'm writing over here to you, that what is happening in the nucleus. First of all, I'm writing in nucleus, the electrons and protons are interconvertible are interconvertible and they interconverts with the half-life of 20 minutes. So we will discuss that in the radioactivity chapter. So in the nucleus, the electrons and protons are interconverting. After some time, proton get converted to sorry, here it is neutrons, sorry. In the nucleus, the neutrons and protons are interconvertible. That is, electron is converting to proton and proton is converting back to the neutron. The neutron and protons are interconverting after some time period. So that was the discovery of neutrons, and I'm repeating it again that in the nucleus we were having the neutrons and protons. The neutrons are neutral, means that they are not deflected in the electric and magnetic field, and the mass of the neutron is equal to that of the mass of proton. So I'm coming to the conclusion. So now we will discuss the final conclusion of the experiment of James Chadwick. The very first conclusion is that I'm writing there is presence of neutrons of neutrons in nucleus with zero charge and mass equal to that of proton. Mass equal to that of proton. The second point, the hydrogen is the only element in a periodic table who does not have neutrons. Now, the third point is that the atom on the whole is neutral. That means the number of electrons will always be equal to the number of protons, and the number of electrons or the number of protons is called atomic number. It is signified like Z. Now the fourth point, the number of protons plus number of neutrons is called nucleons, or you can write mass number. Now, out of the three fundamental particles, the fifth point, out of the three fundamental particles, electrons and protons are electrically charged, that is, electron is negative charged and proton is positive charge. And on the other hand, neutrons and protons have masses, whereas the mass of electron, whereas the mass of electron is negligible. So that was the discovery of neutrons that James Chadwick have done in 1932. He performed an experiment in which he bombarded the alpha particle on beryllium atom, and after the bombardment, the new particle rays were emitted, which were not deflected in the electric and magnetic field, which confirms that the particles of that rays were neutral, neutral, and that were named as neutrons. So that's the nuclear reaction that I have written, that beryllium after getting struck by alpha particle gets converted to carbon, and the rays are emitted which were composed of neutrons, and in nucleus the neutrons and protons are interconvertible with each other after certain time period, which we will discuss in the further topics of radioactivity. So that's all for today. In the next lecture, I am going to solve the numericals which were based on the number of electrons, protons, and neutrons in an atom. It will help you to clear your concept more efficiently. So, I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then they can contact me. My phone number is mentioned on thumbnail of the lecture. Please like, subscribe, and share my channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.